Good morning, everyone. I'm from the farm. Welcome back to the course Food Waste Management. We will conclude the second module of this study unit with a very important and also very interesting lesson about environmental sustainability assessment of food product design and production method. In particular, we are going to discuss the assessment of food product design using sustainability criteria, life cycle assessment, certification, and environmental product declaration for food products, and finally, assessment of food production methods. Firstly, we are going to see the assessment of food product design using sustainability criteria. During the design of food product, we have to make several decisions about ingredient and formulation, nutritional profile, shelf life and preservation, packaging material, portioning and consumer use, and finally end of life impact of the product. What kind of food product can be considered sustainable? It should have this characteristic including minimum environmental impact. So the producer should prefer low impact ingredients, efficient processing, and sustainable packaging. Efficient research use mean minimizing input through precision agriculture, efficient equipment, and renewable or low input ingredient. Minimum waste generation means reducing loss along the chain through extended shelf life, appropriate portioning, and use of byproduct or upcycled ingredients. Compatibility with circularity. Designing for recyclable or compostable packaging using byproduct ingredients and enabling material to stay in biological or technical cycle. And finally, nutritional values with lower impact, which means the product should deliver sufficient nutrients with minimum environmental burden. Life cycle assessment is a practice that evaluates environmental impact from raw material to end of life, guiding decision on ingredients, processing, packaging, and distribution. In a life cycle assessment, we have to evaluate the following things, including ingredients production, processing requirement, packaging, manufacturing, distribution, and cold chains, consumer use, and end of life, including both packaging and food waste. The impact that should be considered during the life cycle assessment, including carbon footprints, water footprints, land use, eutrophication and acidification, energy consumption, packaging footprints, and finally, food waste potential. How to perform life cycle assessment? I will show you the procedure step by step. We start with the evaluation of ingredient selection and environmental impact. Ingredient choice strongly shape a product environmental footprint because most impact originates in primary production. Firstly, we consider the renewability. We prefer fast regenerating, sustainably grow crops over non-renewable or slow renewing resources. Then agricultural environmental footprints include emission, water use, land occupation, fertilizer and pesticides, and soil impact. Transport distance or food miles is about air freight and regenerated goods generally have higher footprints, so local and seasonal sourcing should be preferred to reduce emission. In biodiversity protection, we avoid ingredients that link to monoculture, deforestation, and habitat loss. The certification like Organic Fair Trade Rainforest Alliance can make the ingredient become more reliable. And the use of upcycle or byproduct ingredients can reduce waste and avoid new agriculture impact. The choice of packaging material is very important because packaging is essential for protection and shelf life but adds environmental burden to material use, production, and disposal. There are several choices for packaging material, including recyclable plastic, biodegradable or compostable material, paper and cardboard, and glass or metal. Each material can have its own pros and cons. For example, recyclable plastic require less energy for their production, but their disposal can be problematic. Generally, biodegradable and compostable material are more preferred, but at the disposal phase, they require specific and appropriate conditions. Paper and cardboard production can require a lot of water use, while glass and metal are perfectly recyclable. But also the production require a lot of energy use and also the transportation can generate more emission because they are heavier. Packaging life cycle consideration include material sourcing impacts, production energy use, recyclability, and disposal. Packaging to products ratio is very important because the packaging should be minimum, but it should be sufficient to protect the product. Role in food waste reduction. Usually, innovative packaging has slightly higher footprints, but since they can reduce spoilage better, it can often justify. The third step is the evaluation of shelf life and food waste. Since food waste often have a larger footprint than packaging or processing, extending shelf life is a key sustainability strategy. Longer shelf life can reduce waste and typically lower overall environmental impacts. There are technology and practice that can be applied to extend the shelf life of food product. For example, modify the atmosphere packaging or MAP. This is a technology that adjusts the internal gas composition of the product. In this way, it can slow down oxidation and microbial growth. Active packaging uses oxygen scavenger, moisture absorber, and antimicrobial to prevent spoilage. Mine heat treatment. Now, this technology are not used to extend the shelf life of food too long, but it can preserve the quality with lower energy use than food sterilization. Fermentation is a process that increases the acidity and lowers the pH of the product, extending its shelf life, and it can also valorize surplus raw material. High pressure processing is a non-thermal microbial inactivation that preserves nutrients and sensory quality. The next step is nutritional environmental optimization evaluation. The sustainable design evaluates environmental impact related to nutritional value delivered. This approach can help identify formulations that maximize nutrition while minimizing ecological harm. So it means the food product should deliver sufficient nutrients but with minimum environmental impact. There are some indicators that can be used for this evaluation, including impact per gram of protein, It highlights the efficiency of legume or soil versus the high footprints animal proteins. Impact per kilogram shows that staple crops have lower impact per calorie than animal-based or energy-dense food. Micronutrients density versus environmental burdens. Food rich in vitamin and minerals can offer high nutrients at lower environmental costs. There are certification and environmental product declaration that help verify and communicate the sustainability performance of food products. This document can increase transparency, ensure credibility, and help consumer and supply chain identify products that meet specific environmental or ethical standards. Firstly, we have Environmental Product Declaration or APD. These documents are science-based, standardized that report a product's environmental impact over its full life cycle. They allow fair and transparent comparison between products. Usually, the indicators that are reported in this document include carbon footprints, water use, land use, eutrophication, resource depletion, and waste generation. We also have product certification that verify that food meet the defined environmental, ethical, or production standard, using independent audits and inspection. This certification do not provide detailed environmental metrics like APD, but they complement APD by confirming compliance with specific sustainability criteria. So there are some certification, some most common certifications that maybe you have already seen in food packaging, like organics, vegan certification, and non-GMO. So we have just concluded the assessment of food product design. Now we move to the assessment of food production method. The food production consists of primary production, including agriculture, livestock, aquaculture, and fishery, and secondary production, which include processing, manufacturing, packaging, and logistics. Both stages shape the environmental footprints to resource use, emission, and ecological impacts. In the assessment of agricultural production method, we have to care about many factors like land use and biodiversity, in which we evaluate how farming transforms lands and affect ecosystem. We have to assess the emissions from machinery, livestock, and fertilizer, which is the greenhouse gas emission. About the pesticides and chemical use, we have to evaluate the toxicity and ecosystem impacts. About water use and irrigation efficiency, it based on water footprints. Efficient irrigation reduce demand and support long-term water availability. Nutrients pollution. The excess fertilizer causes runoff and eutrophication, which is a phenomenon that we have mentioned in the previous lesson. Animal welfare is attracting more and more attention. Sustainable livestock system emphasize better living conditions, reduce antibiotic, and improve feeding, benefiting both ethic and environmental performance. For the assessment of food processing method, we have to evaluate the energy consumption. In a processing stage, there are some operations that require a lot of energy, and They can be, for example, heating, cooling, and drying. For the assessment of water use and wastewater treatment, we have to assess total water use, recycling system, and effluent treatment to reduce pollution. In waste generation and circularity, we examine reuse of organic residue and packaging waste, and finally processing impact on environmental performance, including processing choice that affect energy use and shelf life. In the evaluation of transportation, distribution, and storage, we have to consider the cold chain's energy use. Refrigeration consumes high energy and may leak high global warming potential refrigerants. So, efficiency improvement and natural refrigerants as a solution to reduce the impact. Transport footprints depend on distance, transport mode, and logistic efficiency. For example, air freight had the highest emission, while maritime and rail are more efficient. Route optimization further lowers the impacts. We have integration of sustainability criteria. So when the strategy are integrated, they can bring a better result. We have life cycle assessment for agriculture and processing. We qualify impact across the life cycle and identify hotspots for improvement. FAO sustainability principle ensure environmental integrity, economic resilience, social well-being, and also responsible governance. Then we have a series of ISO standard about life cycle assessment, water use, carbon footprints, and energy use. Sustainable agriculture certification like organics, global GRP, and other verified soil protection. Reduce chemical, biodiversity support, and animal welfare. And finally, there are also food specific indicators that include nutrients runoff potential, pesticide risk, water use intensity, or storage energy need, offering category specific insight. Thank you for joining me today. I hope you enjoyed the lesson. We have concluded the second module of this study unit. In the next lesson, we will move to the third module, which is about sustainable waste and resource management practice. See you next time.